Hello children, let's understand a wonderful topic of Rutherford's model of an atom. So after Thomson's model, there was one incorrect or inaccurate postulate which was then corrected by Rutherford. So what was the experiment that was done by Rutherford? So Rutherford did a gold foil experiment. What is the name? Gold foil experiment, in which he took the gold foil. See, there is a thin gold foil here, and he bombarded alpha particles on a thin gold foil in his experiment. Children, alpha particles are helium ions. Alpha particles, the symbol of alpha is this. Alpha particles are helium ions with atomic number 2, mass 4, and they are positively charged ions, 2 plus charge. Each ion has 2 plus charge. So they are doubly positive charged helium ions. So these alpha particles, they were striked on the surface of gold foil, and then various observations were recorded. So according to Rutherford, he assumed that there will be some deflections going on. So in his gold foil experiment, what he did, see, there is a gold foil, it is very thin, it was as thin as just 1000 atoms in a layer. So why he chose the gold foil? The only reason was this, that the gold foil can be made as thin as 1000 atoms per layer. So he took the gold foil, though he could have taken any other metal. Even if you take any metal, the result will be same. So he took the gold foil, and this is the radioactive substance from which alpha rays will be passed. So these alpha rays will strike the atoms of the gold foil, and what he saw were the three main observations. First, he found that few alpha particles were actually moving by small angle, see, small angles, and few were actually moving by large angle. They were deflected by large angle, and few alpha rays were coming back. They were rebounding. So there were three observations that was recorded, and there were three conclusions for those observations. So keep in mind, you should know the diagram of the Rutherford model. So what is happening? We are passing alpha rays to the gold foil. And why we chose gold foil? Because we can make it very thin. Then there were three main observations that were recorded. Few alpha particles deflected by small angle, few by large angle, and few rebounded back, and few just passed through it, right? So the subatomic particles in the gold atoms were predicted to deflect alpha particles, but not too much, to a very small angles, but he actually found the large deflections. So this is what the simulation of the gold foil experiment, where you will see these are the atoms of gold foil, and see what is happening. See very clearly. So you will find that few of them are just passing, few are passing by some angles, and few are actually returning back. So few alpha particles are returning back, few are passing by small and large angles, and few are just passing through it. So how is it possible that rays can pass through it? How is it possible? So let's understand what are the observations and conclusions. So first of all, he found that most of the fast moving alpha particles passed straight through the gold foil. They moved straight through the gold foil. They didn't stop. Why? Because what is the charge of alpha particle? It is 2 plus charge. It is positively charged particles. It means there are positive charge particles and they can pass directly through it, which clearly indicate that there is lot of empty space. There is lot of empty space in an atom. Then second observation he found was some of the alpha particles were deflected by small angles or large angles by the gold foil. So what was the conclusion? The conclusion was that if they are deflected by some angles, it means alpha particles being positive. How a positive charge will be deflected? It will be deflected by some positive charge only. It means there is some positive charge. There is some positive charge present in the atom, and basically it is present at the center of the atom, right? Because positive will be repelled by positive only. So, if alpha particles are positively charged particles, they can only be deflected by positive charge, right? So, positive charge must be present at the center of the atom. Then, the next very important observation he found was 1 out of 12,000 particles appeared to rebound. There were some rays which deflected back. Why? Again, alpha has +2 charge and it is heavier particle. So, the conclusion was all the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom, because the deflection was only occurring when the ray was actually passing through the center. So, when the alpha rays were passing through the center, they returned back their path. So, when they rebounced, why? Because this alpha particle being so heavy was able to rebounce. It means there is something here which is positive and hard and dense. And what do we call this center which is hard and dense and positive charge? We call it nucleus. Rutherford said this term, nucleus. So, what was the conclusion? All the positive charge and mass of the atom were concentrated at the center in a very small volume within the atom. So, what were the inferences? Before proceeding with the inference, let's watch an animated video we have.
Discovery of the nucleus. Rutherford's experiment. In order to test J.J. Thomson's atomic model, Rutherford set up the following experiment. He reasoned that if positively charged mass present within the atom is thinly spread, then any positively charged particle moving with sufficient kinetic energy would easily penetrate through it. Thus, if a thin foil of gold is exposed to fast-moving positively charged particles, then the particles should just pass through the foil. These particles can be detected by zinc sulfide screen placed behind the gold foil when scintillations are produced on the screen. Rutherford selected alpha particles as missiles to hit the atoms. Alpha particles are the nuclei of helium, He2 positive, having mass of 4 AMU and 2 units of positive charge. It is a nucleus consisting of 2 protons and 2 neutrons. The alpha particles were obtained from radium and then accelerated. These accelerated particles were condensed to a narrow beam by passing them through positively charged parallel plates. They were finally directed against a very thin gold foil placed at the center of a circular zinc sulfide screen. Rutherford expected the alpha particles to pass through the gold foil and produce bright scintillations at point A. However, to his surprise, some of the scintillations were produced in regions BB and CC. These observations can be explained only if we assume that positive charge in the atom is concentrated in a very small place within the atom. Following is the summary of Rutherford's experiment. Most of the alpha particles passed through the foil straight without suffering any change in their direction. A small fraction of alpha particles deflected through small angles and few through large angles. 1 out of 12,000 particles appeared to rebound. In other words of Rutherford, this result was almost incredible, as if you fire a 15-inch shell at a piece of tissue paper, and it comes back and hits you. Rutherford called this concentrated positively charged mass within the atom nucleus and the particles present within the nucleus nucleons. When alpha particles approach this concentrated positive mass at right angles, they get deflected almost through 180 degrees. However, if they pass very close to the concentrated positive mass, they get deflected through large angles. Much the same way, if they pass just close to the concentrated positive mass, they get deflected through small angles. But if they do not pass close to the concentrated positive mass, they do not get deflected. That is, they just pass through the gold foil. as most of the alpha particles are able to pass through the gold foil, producing strong scintillation at A, the following conclusions can be drawn from the experiment. The nucleus of an atom is positively charged. The atom, on the whole, is relatively empty, and the positively charged mass in the nucleus is concentrated over a very, very small space. Nucleus of the atom is very dense and hard. The angle through which alpha particles get scattered depends upon the angle at which they approach the positively charged nucleus of the concentrated mass. Drawback of Rutherford's atomic model. The comparison of electrons to the planets in the solar system is the main drawback of the Rutherford's atomic model. It has been found that if an electrically charged particle revolves around a circular path, then it always radiates out energy. Thus, if an electron moves around the nucleus, it must continuously radiate out energy and hence gradually move towards the nucleus in a spiral path till it collides with the nucleus.
So children, I am sure that you have seen the animated video. So let's discuss the inference of the Rutherford model. So an atom contains a positively charged center or the nucleus. The entire mass resides in the nucleus of an atom. The electrons revolve around the nucleus in a circular path. And then he said the size of the nucleus is very small as compared to the size of an atom. So these were the inferences that we got from the Rutherford model. So if I ask you that who discovered nucleus, what is the answer? Rutherford, yes. And how? By gold foil experiment he discovered nucleus, and he discovered that nucleus is positively charged, dense, hard and concentrated in a very small volume, right? But there are some drawbacks about Rutherford model. Though he clearly explained that electrons revolve around the nucleus, but he could not explain the stability of atom. He could not explain the stability of atom. Why? Because if electrons revolve around the nucleus, they will go into the nucleus, because electrons are negative, nucleus is positive, negative, positive attract each other. So how the atom is stable? If electron will go into the nucleus, how it will be stable? It was not explained by Rutherford. So what was the problem with the Rutherford experiment? That he was unable to explain the stability of atom. Rather, he suggested that electrons are negative charged particles. Due to the acceleration, they will move around the nucleus and they will fall into the nucleus. So nucleus is positive and electron is negative due to the attraction. The force of attraction will lead to acceleration, and this accelerated motion will lead to the electron going towards the nucleus, and electron will fall into the nucleus and hence atom will collapse. So it means atom is destructible? No, atom cannot be created or destroyed. So definitely this drawback, this is the main failure of Rutherford model. But yes, he was able to find the nucleus present at the center. That was the achievement the Rutherford model has. So let's read the drawback. The electrons revolve in a circular path around the nucleus and are expected to undergo acceleration, which will radiate energy. So this energy is radiated, and due to the accelerated motion, electrons will move towards the nucleus and will fall into the nucleus such that atom will collapse. So it could not explain the stability of an atom, that how atom will collapse. I hope you have understood. Thank you.